Hi everybody, it's Miss Austin. I'm going to be doing the review packet for the upcoming test over exponentials and logs. So the first question here is just asking us which of the functions are exponential. An exponential function has a constant as a base being raised to an exponent that is a variable. So for 1a, right away I know it's not because the exponent needs to be a variable. So no, the exponent is not a variable. Letter B, I've got a number, a constant as a base, and I have an exponent that has a variable in it. This is a yes. It says if it is, state whether it's exponential growth or decay. If the base is bigger than 1, it's growth. So this is exponential growth. Letter C. Again, I can tell right away this is a no because look at the exponent. It's not a variable. So I'm just going to arrow down. No. An exponential has a variable in the exponent position. Letter D. Looking good. I have an exponent for the variable. A variable as the exponent and a constant number as the base. Yes. And is this growth or decay? If the number is between 0 and 1, it represents decay. Greater than 1, growth. Between 0 and 1, decay. So this is exponential decay. Consider the function f obtained by applying the following transformations to the graph of y equals log base 3 of x. So I'm going to do this first before I try to graph it. So stretch vertically by a factor of 1.5, that's going to be y equals 1.5 times log base 3. Reflected horizontally, that's when I make my x negative. And then down 7, I put a negative 7 at the end. This is log. Log graphs have vertical asymptotes that are determined by the number with x. So there's nothing in there with x. So it's just 0. So my asymptote is at 0. The base determines whether it's growth or decay. So it's growing, but it's been reflected across the y-axis. So it's actually over here. So now I know it's over here. And you just need one good point. I know I'm going to plug like a negative 1 in. If I plug a negative 1 in there, that would be 1.5 log base 3. Negative of negative 1 would be 1 minus 7. You could do this on your calculator if you wanted. I'm going to just do this in my head. That is 0. 0 times that is 0, and 0 minus 7 is negative 7. So when I put a negative 1 in, it spit out a negative 7. So something like this, negative 1, negative 7, and I know it's looking something like this. Okay? Whoopsie. Lost you for a minute. Hopefully the talking still was there, but the video stopped. Again, I plugged a negative 1 in, and that turned it to 1. You could type that into your calculator or do it mentally. When I put the negative 1 in, it spit out a negative 7. Okay? Next page. All right, now we're on to an exponential. Exponentials have horizontal asymptotes determined by the k value. This is decay, but it's been reflected across the x-axis, so it's down here, but it's been shifted up 6. Okay, that's just me brainstorming. So this is a vertical reflection, the negative, or across the x-axis. The plus 4 shifted it left 4, and then up 6 for this right here. So again, that's my asymptote. I'm up here at 6. You could say y equals 6. And I already brainstormed that it's like this, so it's coming in to that asymptote from underneath. And I like to turn the exponent into a 0. So I'm going to let x be -4. So if I let x be -4, again, you could just go to your calculator, type it in, get points from the t-table. You can put a 0 in. I'm putting -4, which makes this 0. Anything to the 0 power is 1. And that would be -1 plus 6, so that makes 5. So 1, 2, 3, 4, and there's 5. Something like that. And make sure that you label the thing. Again, if you wanted to use a calculator, right, you just type it in. You could do -0.5 to the, I put a -4 in to make that 0 plus 6. Oh, I put the 6 in the wrong spot, sorry. -0.5 to the 0, and then put the plus 6 here. That's how I got 5. You could also type it in here. You can put the rule in y equals and go to your table, second table, and go get points here. All right, domain of exponentials are all reals. There's no restrictions. The range is, the highest is 6, the lowest is -infinity. So you could either say y is less than 6, or you could go -infinity up to 6, either one of those. Asymptotes, you got the one horizontal asymptote, y equals 6. Notice it says write the equation. Describe the boundedness. It's bounded above. It's trapped up above. Bounded above. Where is f increasing? If you get confused, like draw arrows. If you read a graph from left to right, this graph is always increasing. So it wants to know what x interval. So that's from -infinity to +infinity. It's always increasing. Is it ever decreasing? Never. Name any and all x values at which f has an extreme point. Like is there a max or a min? No. It's going down to -infinity and it's slowly approaching 6. It's always increasing to 6. So there are none. And then the limits. As you walk to the left, as you go to -infinity, where's the graph going? To -infinity. And as you walk to the right, towards +infinity, the graph is approaching 6. All right, now we're on to some solving. Exponentials undo logs, logs undo exponentials. That's the key to this test. So this is an exponential. So once the base is isolated, which it already is, we're going to rewrite it as a log. Log base 7 of 2401 is the power I'm looking for. On the calculator, our calculators have this base button, math, alpha math, log base 7. The calculator has stored in it the power I need to raise 7 to get 2,401. The answer is 4. You could check it. 7 to the 4th is 2,401. Okay, this is a log. So I'm going to end up converting it to an exponential, but I need to get the log expression alone. See how it's been multiplied by -2 and 14 is being added? I'm going to subtract 14. -2 times log base 9, 5x plus 1, -6. Divide both sides by -2. Log base 9 of 5x plus 1 equals 3. Now my log expression is isolated. Now I'm going to convert it to an exponential. 9 to the third is 5x plus 1. 9 to the third is 5x plus 1. I do this on my calculator. 9 to the third. 729 is 5x plus 1. Solve for x. subtract the 1, divide both sides by 5, 145.6. Okay, and you can check this too. Take that answer, type it right there, and type that left-hand side into your calculator. And it should spit out 8. Letter C, this is an exponential, so eventually I'm going to convert it to a log, but I got to get the base isolated. So first I would subtract 8, 2, 3, 2, and I got to get rid of this, divide by 3, 94 equals e to the 2 minus x. All right, now my base is isolated, so now I'm ready to write it as a log. Log base e of 94 is 2 minus x. And type this into your calculator. Now, the thing to remember is log base e is ln. You can still type it in like that if you want, but I'm going to do ln. So natural log 94, 4.543. 4.543 is 2 minus x. I'm going to solve for x. 2.543 is negative x. I want positive x, so I'm going to divide both sides by negative. So final answer, negative 2.543. Again, how do we check? I'll show you how to check this one. So you go 3 times e to the 2 minus negative 2.543 plus 8. And when I hit enter, it should equal close to 290. 289.9. Close. Letter D is a log. This is going to get switched to an exponential if the log is isolated. Oh, it's already isolated. There's nothing being multiplied by it. There's nothing being added. So I'm just going to write this as an exponential. So 0.2 to the negative 4 is the answer. Also, if it helps sometimes, you can put the negative 4 over there if it's easier to see. 0.2 to the negative 4 is the answer. Go straight to my calculator. 0.2 to the negative 4, 625. Again, take the time to check your answers though, okay? Number 5, this is just seeing if you can do mental math. Again, this is 3 to what power is 81? The 4th power. 35 to what power is 1? The 0 power. ln means log base e. E to the what power makes e? 1. 1/4 to the what power makes 16? Well, I know 4 squared is 16. So how did the 4 go from being on the bottom up to the top? It was a negative 2. Okay, and then here, if an exponent is being raised to a power that has a log with that same base, those undo each other. So this is just 93. Okay, and then here, 38 to what power makes 38 to the negative 5? Negative 5. These essentially wipe each other out. Just like that one, those wipe each other out. All right, here's just kind of practicing again. There's really nothing like this on the test. This is just like the basics to help make sure when you get to the solving problems. So this is log, this is the base, the thing being raised to the power of 80 equals x. The exponent is always the answer to the log. Now I'm writing it as an exponential. 2 to the negative 4 is tens, hundreds, thousands. 625 ten thousandths. 2 to the negative 4 is 0.0625. Okay, this is if you happen to have a calculator that doesn't have the log with different base buttons. Okay, so common log base 10 is just log of 3,500 divided by log of 6. That'll give you the same answers if you type that into your calculator just like that. It's the log of this divided by the log of the base. And you can do that either with base 10 like I have or with ln. Number 9, we're expanding. So before I do this, I want to clean this up a little bit. So I'm going to write log base 3, 49 x to the 4th, and then this would become y5 z15. Now all that's being multiplied, so I'm going to break it apart by adding. So I have log base 3 of 49 plus log base 3 of x to the 4th plus log base 3 of y to the 5th plus log base 3 of z to the 15th. And then notice in the end, no exponents. So all this one's good, so I can bring this down, and this down, and this down. That's your power property. So the final answer, log base 3 of 49 plus 4 log base 3 of x plus 5 log base 3 of y plus 15 log base 3 of z. This is expanding. Okay? Expanding. This, okay? ln, no difference, just log base c. Two logs that are being divided can be expanded through subtraction. So this is the natural log of 2a to the 5th b minus the natural log of b to the 8th. Now those are being multiplied. So I need to break those apart with addition. Natural log of 2 plus the natural log of a to the 5th plus the natural log of b minus the natural log of b to the 8th. Now I need, look, no exponents. Don't forget that. So I have the natural log of 2 plus 5 natural log a plus the natural log of b minus 8 the natural log of b. And then this one's a little tricky because look here how they're the same. You have one of these minus 8 more. So those are kind of like terms. So those could be condensed to the natural log of 2 plus 5 natural log of a plus, actually minus 7 of them, right? Negative 7 natural log b. Okay, now we're reversing. Now we're condensing. Okay, so now we're going to take this and make it look like this, a single log expression. Okay, but I'm going to take a little intermission. I'm going to post this as my part 1, and then I'll post the rest of this as part 2. See you soon.